So I'm going to do both magnesium and calcium chloride, and I'm going to show you the two different ways you can do it and some errors that are going to come up as we do it. So first of all, always write the equation, have an idea of what you're going to get, even though you're not meant to know that it's MgO. And so for this first one here, so I've weighed the crucible and the lid, then I've had magnesium in it and I've written that down. And then I've put crucible and the lid with magnesium after I've heated it. And so that's all right here. And so basically what you're going to be watching there is some errors that can occur when you're doing it. So you can see that the magnesium oxide comes off as a gas. So you have to sort of not let too much oxygen in by putting the lid over it. So that won't burn so quickly, and the lid on top of it also contains the magnesium oxide gas coming off, besides also slowing it down so it doesn't burn too quickly. And so what I've done here is you minus various things from each other. So minus these two and you get magnesium, minus that one and that one you get MgO, and then you minus these two and you get O. So number of moles is mass on molar mass. That's how many moles of magnesium that I started with, and I've calculated how many moles of oxygen added to it to increase the weight. And so you divide it by the smallest number, which is here, and you get 1.2, which is sort of borderline. 1.3, you times it by 3, so you'd have like 3, so you'd have like 4:3 or whatever. And this one here, so I've rounded that down just to MgO, so I haven't done percent error or anything else. So for this one here, you always want to do a reheating. So what I've got here is I've got too much. I want to get equal amounts. So I want to get 0.0164 on both sides. So I don't have enough oxygen that has actually joined to it. Now that could be, I need to do a reheating to see whether that mass will increase further, to say that not all the magnesium has burnt. So there's still magnesium oxide to increase the weight. Now, if I do a reheating and there is no change, then the lack of weight is probably then due to a different thing, which is loss of magnesium oxide powder. And so doing the second reheating will tell you whether the reaction's finished or not. And if it is finished, then and you're still not getting it heavy enough, it's probably due to the lack of magnesium oxide powder rather than the magnesium not fully reacted. Another thing that students don't usually consider enough is the magnesium perhaps wasn't pure, so you need to check the stock package. And there's magnesium oxide on the outside already, so it had already oxidized and wasn't clean. And if you think the soot makes a difference, it doesn't. I'll try and put a link to it, the other lab, up in the description right there. Okay, so we're just going to move to the next one, which is calcium chloride. Now this one's slightly different. You could do copper sulfate pentahydrate as well, but when these things crystallize out, you write the 2 here instead of H2O in brackets 2, because it's called water of crystallization. It can come off and go back on. And so here you can say I've just done the same thing, measured the weight with the calcium chloride in it, and then the weight when it's left, minus it from the crucible and the lid to get all of these things broken down. And so number of moles is mass on molar mass, so how many moles did I end up with? And then divide everything by the smallest number. And so what I end up getting is 4.5 instead of 2. So I've got way too much water. And so as you can see, when I was heating it up, I purposely overheated it as much as I could instead of doing a gentle heating. And you can see the bubbling quite clearly. So the water could be escaping, but I could really smell the chlorine. So it was definitely decomposing the calcium chloride to calcium and chlorine, not just the splashing of water. And then you could see it goes red hot, so that is also probably decomposing throughout the entire experiment. And so that explains why there was so much loss. And how do you know there was a loss? Well, if the water is meant to be this much, that indicates that you have you think that all the loss of mass is due to the water, where it's not. So the water should only be 2. And so why is there a massive decrease in the weight it's not just due to the water, it's either losing material or calcium chloride itself is breaking down. And so reheating, if you did it gently, shouldn't help, and it should give the same value. If you reheat it like I did, you're just going to completely just keep on destroying it. So heat it gently like the method says, and then hopefully a reheating will confirm that you have heated it gently to the correct amount, and extra reheating doesn't do anything and it doesn't destroy it, so that's perfect. So reheating is vitally important for all of these. And just out of curiosity, I didn't really leave it for 10 minutes, actually only 5 minutes, and you could see there was an increase in mass. And so this is a very hydroscopic compound, so it absorbs water. And so instead of putting the lid on to stop stuff getting out, we're putting a lid on to stop water getting in after it's been dried out. So you can see they're very different experiments. One's losing, one's gaining, one's got a lid on for different reasons. So make sure you do research and pay lots of attention to what's going on in the experiment, because there is quite a lot going on.